Yes, hello everyone. In today's class, we see unit number 4, very basic concepts, right? So, unit number 4 is elementary combinatorics. Elementary combinatorics, isn't it? Elementary combinatorics. So, in this, first we see what are the basics of counting. Basics of counting. There are two rules of counting. One is sum rule and the other one is product rule. Sum rule is if an event can be performed in m ways and another event can be performed in n ways, and if these two events cannot be performed simultaneously. Please understand that these two events cannot be performed simultaneously. Then one of the two events can be performed in m plus n ways. M plus n ways. Okay. So there are two events. These two events cannot be performed simultaneously. That means one after the other can be performed. Say for example, there are A and B two events. A can be performed in two ways. After performing of A, there is a event B. B can also be performed in two ways. Okay, A can be performed in two ways as well as B can also be performed in two ways. So how many number of total ways? So A can be performed in two ways plus B can be performed in two ways. Therefore, total number of ways is equals to 4. So this is the sum rule. It is called sum rule. Sum rule means if an event can be performed in m ways and another event can be performed in n ways, and both events can be performed in m plus n ways. M plus n ways. Clear? Right. Now coming to the example. If there are 14 boys and 12 girls in a class, assume that there are 14 boys and 12 girls in a class. Find the number of ways of selecting one student as class representative, CR. CR is nothing but class representative. All you know that, right? So here what is the condition? There are 14 boys. Total number of boys are 14. Total number of boys are 14. Clear? Boys are 14. And how many number of girls are there? 12. Okay. We need to select one student as CR. One student as CR. In how many ways we can done this independently? That means one boy can be selected. If we want to select a boy, one boy can be selected in how many number of ways? 14 ways. Among the 14 boys, one boy can be selected in 14 ways. Clear? Among 14 boys, one boy can be selected in 14 ways. And among how many girls are there? How many girls? Right, 12 girls. So one girl can be selected in 12 ways. Among the 12 girls, one girl can be selected in 12 ways. So the total number of ways are 14 plus 12, that is equals to 26. Okay. So like this we can do problems on sum rule, right? So we can do so many problems like this. Right, next rule is product rule. So what is product rule? If an event can be performed in m ways and a second event can be performed in n number of ways, and if the number of ways the second event performed cannot be depend upon the performance of the first event, okay, then the two events can be performed simultaneously in mn ways. So we will see one example for this. A person has 3 shirts and 5 ties. Then find the number of ways of choosing a shirt and a tie. A person has 3 shirts and 5 ties. Okay, that means he can select a shirt from 3 shirts in 3 ways, and he can select a tie from 5 ties in 5 ways. That means first work can be done in 3 ways, second work can be done in 5 ways. So the total number of ways both the works can be done in m into n ways. 3 into 5, that is equals to 15 ways. Is it clear? Next, coming to the One more example. Three persons enter into the car. Three persons enter into the car where there are 5 seats. Okay, 3 persons are there, 5 seats are there. In how many ways can they take up their seats? So there are total number of seats available 5 and the persons are 3. If first person enter to the car, how many seats are there? 5 seats. That means he can occupy one of the 5 seats in 5 ways. He can choose any one of the 5 seats in 5 ways. Now, if he choose any one of the 5 seats, how many seats are left over? Yes, exactly 4 seats are left over. If second person enter to the car, then how many number of ways he can choose the seat? Only 4 ways, because already one person occupied. So 4 ways. That means first work can be done in 5 ways, second work can be done in 4 ways. Now 2 seats are already occupied, one person is remaining. Now in how many ways that person can choose a seat? That means how many seats are available for him? Yes, exactly 3 seats are available because 2 seats are occupied. Therefore, he can choose his seat in 3 different ways. So total number of ways are 5 into, that means first work can be done here in 5 ways, second work can be done here in 4 ways, and third work can be done here in 3 ways. Clear? So 5 into 4 into 3. So 5 into 4 into 3 gives us 60 different ways. Clear? Right. So in this way we can done this type of problems. This rule is called product rule. Exactly. Okay. So we move to the next concept. So the most important concepts of fourth unit are permutations and combinations. I think already you have studied this concept in your intermediate second year level, but we are revealing all those concepts once again. Permutations and combinations, right? First, before going to know what is permutation, we need to know some basics. So first one is factorial notation. What is factorial notation? Okay, factorial is nothing but the continued product of first n natural numbers. The continued product of first n natural numbers is defined as factorial notation. That means 1 comma 2 comma 3 so on n are natural numbers. The product of 1 2 3 so on n is the called or is defined as n factorial. Okay, the symbol of factorial is this. Okay, we can denote n factorial like this. Okay, n factorial is nothing but we can write from the back to front or front to back. If we write from the ending digit, n into n minus 1 into n minus 2 so on 3 into 2 into 1. If we write from beginning 1 into 2 into 3 up to so on n, we can write in both ways, right? For example, if I want to find 4 factorial, 4 factorial is equals to from backwards 4 into 3 into 2 into 1, or if I move from frontwards 1 into 2 into 3 into 4, like this we can write. So after multiplying what we get? 24. Like this 5 factorial is equals to 120. So continued product of first n natural numbers. Okay, if I get n plus 1 factorial, if I want to find n plus 1 factorial, so what is n plus 1 factorial? n into n into okay. So here this is the problem actually. N plus 1 factorial is equals to 12 into n minus 1 factorial, which is the given problem. N plus 1 factorial, n plus 1 factorial, right? So we see clearly now. If find, this is the problem. If n, find n, if n plus 1 factorial is equals to 12 into n minus 1 factorial. Okay, so what is given? N plus 1 factorial is equals to 12 into n minus 1 factorial. So by using the factorial notation, we can reduce n plus 1 factorial consecutively up to what is our desired destination. So here n plus 1 factorial I can reduce consecutively by 2 times. I am getting n plus 1 into n minus 1 factorial, because I need only n minus 1 factorial. If I can write n minus factorial in the LHS side, we get cancelled n minus 1 factorial on both sides of this equation. So I am writing n plus 1 factorial as n plus 1 into n minus 1 factorial, that is equal to 12 into n minus 1 factorial. So both sides n minus 1 factorial, n minus 1 factorial get cancelled. What is the value remaining in the LHS side? N plus 1 into n. So that is equals to 12. Now on calculating this, we get n square plus n minus 12 is equals to 0. By factorizing this, we get n plus 1 into n minus 3 is equals to 0. So n is equals to 3, n is equals to minus 4. So in factorial notation, we only get n values positive. There is no negative values for factorial notation. So n is equals to minus 4 is not defined. This is not applicable, admissible value. So only we take the value n is equals to 3. Clear? Now compute 20 factorial by 18 factorial. This is the question given here. So how do we find 20 factorial by 18 factorial? 20 factorial can be reduced to 18 factorial. 20 into 19 into 18 factorial by already the denominator consisting of 18 factorial. So 18 factorial get cancelled. So if we calculate this, we get 380, right? So this is what factorial notation. Depends on factorial notation, we define permutations. So permutation is nothing but an ordered selection or arrangement. Permutation is nothing but arrangement actually. In simple word, permutation can be said as arrangement. Arrangement itself requires order. Okay? Selection does not require order. But permutation arrangement itself required order. So permutation is said to be an ordered selection. Ordered selection one by one, or arrangement of what? Of given set of objects. Ordered selection or arrangement of what? Some objects are given to us, then if we select that objects in the ordered way or arranging the objects, then it is said to be a permutation. Okay, so an ordered selection or arrangement of given set of objects taken some or all of them at a time is called a permutation of the objects. Okay, some or all at a time. Some for example, if n objects are given to us, if we take total n objects or some objects from the n objects, okay, if we arrange those objects, then that is called a permutation. Okay, now what is the formula for permutation and what is the denotation of permutation, right? How do we denote permutation? Permutations can be denoted by this notation NPR. Here n stands for number of objects given to us. N stands for number of objects given to us. Okay, R stands for number of objects we are taking. The number of objects we are considering, and P stands for permutation. So NPR means the number of permutations formed by taking R objects. The number of permutations formed by the given n objects by taking R at a time. So here it is the formula for NPR. N factorial by n minus R factorial. N factorial by n minus R factorial. Okay. Now we move to the formula. How do we derive this formula? The derivation is not important, but just see here, the number of permutations is nothing but number of ways of selecting or filling n different boxes with R things. So here clearly we can number the total R boxes as we see the example, the car example. According to the car example only, similar to the car example only, this can be done. So 4. Now I am taking the total R boxes. Now I can fill these R boxes in how many number of ways. So if I want to fill the first box, how many choices for first box? There are n choices because n objects are given to us. We need to fill the first box with n objects because in our hand n objects are there. So the number of ways of filling first box is n. Now after filling the first box, how many objects available to us? Only n minus 1, because already we filled the first box with any one of the n objects in one way. Now there are n minus 1 objects are remaining. We can fill these second box by using n minus 1 objects in n minus 1 number of ways. Okay. Now third can be filled in n minus 2. Clear? Very good. I think you understood, right? Because already two objects filled, that means two things are gone. Therefore n minus 2 objects are remaining in our hand. So the third can be filled in n minus 2 ways. So here first work can be done in n different ways. Second work can be done in n minus 1 different ways. These two works simultaneously can be done in n into n minus 1 ways. Now the first two works can be done in n into n minus 1 different ways, and the third work can be done in n minus 2 different ways. So the first three works can be done in n into n minus 1 and n minus 2 different ways, so on. How many number of objects remaining for rth box? So for first box n and n, for the second one n minus 1, for the third one n minus 2, for the fourth one n minus 3. Similarly for the rth one n minus r plus 1. For first one n minus 0. For second one n minus 1. Okay, second box n minus 1, third box n minus 2. Clear? So for rth box n minus of r minus 1. N minus of r minus 1 can be written as n minus r plus 1. Okay, for first 1 less, for second 1 less, for third 1 less, so on. For r 1 less. So n minus of r minus 1. N minus 1 of r minus 1 is nothing but n minus r plus 1. So all these works can be simultaneously done in n into n minus 1 into n minus 2 into so on n minus r plus 1. Okay, so by multiplying and dividing by n minus r minus 1 into so on 3 into 2 into 1 by 3 into 2 into 1, we get the formula as n factorial by n minus r factorial. This is very important to enumerate the permutations of set of different things. Pn of n. Pn of n is npn. Npn is nothing but n factorial. That means the number of ways of arranging n things taken all at a time is n factorial. Okay. So the number of permutations formed by taking all at a time is n factorial. And 0 factorial. 0 factorial is always 1 because nc 0. We are not taking any object. That means it is one way. Okay. Not taking object is also, not arranging object is also one way. 0 factorial considered as one way. Clear? Now we do see some examples of combination. So we see combination. Combination is nothing but an ordered selection of an ordered selection. Combination requires only selection. It does not require the arrangement, right? An ordered selection of a given set of objects taken some or all of them. But when combination comes, this is not needed. Ordered is not needed. So we can omit this ordered selection. Just a selection. And a selection of a given set of objects taken some or all of them at a time is called a combination. Thus, any ordered selection of r objects from a set of n objects is called an r combination of n objects. If it is denoted by CNR or NCR, combination is always denoted by NCR. Okay, the number of all combinations of n distinct objects taken r at a time is given by NCR. That is equal to n factorial by n minus r factorial into r factorial. Okay, is it clear? So these are some important results you need to remember. NC0. So this is the notation we need to use. To represent the combination. Some others are representing combination by this notation. C of n comma 0. Here n stands for number of objects given to us. This stands for number of objects we are taking. Okay, n stands for number of objects given. R stands for number of objects you are taking. Okay, C stands for combination. Okay, Cn0 is nothing but we are not taking any object from the given set of objects. This is also one thing. Nc0, that is equals to 1. Ncn is also equals to 1. Okay, we can take all objects from the given all objects. That is only one way. Therefore 1, because we are selecting. So NCR is equals to Cn of n minus r. So first this is very important. NCR is equals to NC n minus r. This is a binomial coefficient. Okay, these are the some very important formula you need to remember, right? So these are the basic concepts of permutations and combinations and the definitions. In the next class we will see some more examples. Right, thank you very much. Bye.